Recording started.
My name is Daniel Apt with Olanu, and I am project lead for the SMC Clean project. SMC Clean Module 3.3 covers LID and GSI inspection. Chapter 3 in the SMC Clean LID Construction, Inspection, Maintenance, and Monitoring Guidance Manual. An overview of LID and GSI inspections. Inspection's primary purpose is to ensure that LID and GSI measures have been constructed per the design plans, are effectively being maintained, and both to ensure their proper function and performance. There are three types of LID and GSI inspections. During construction, to verify BMPs are being constructed in accordance with the approved design plans. Commissioning and construction complete inspections, which is to verify BMPs were constructed in accordance with the approved design plans. And finally, operation and maintenance inspections, or also called conditional assessments, which verify BMPs are present and functional and that the area is well maintained. This is the LID and GSI measures process of inspections. After the LID-GSI design plan approval, it is critical that GSI-LID inspections take place to ensure that LID-GSI features are constructed per the design plans. The first inspection is during construction of the LID and GSI systems to ensure the proper materials, layout, and protocols are used to ensure proper function when complete. This may include several inspections during construction. When construction is complete, is when the commissioning inspection takes place to ensure the system has been completed based upon the footprint and configuration in the approved design plans. As maintenance of LID GSI systems is critical, O&M inspections should happen at least annually for the life of the LID and GSI system. Finally, for any of the three types of inspections, follow-up inspections may be needed if deficiencies are identified. There is a specific LID and GSI inspections protocol. Use of the inspection protocol is for the three types of inspection and should be used for all three types of inspection. A critical element to inspection is reviewing pertinent information related to LID GSI BMPs and doing that in the office prior to going on the inspection. This should include review of water quality plan, design plans, specifications, and the O&M plan, determining the contributing drainage area of the BMP, identifying the BMP type, configuration, location, and footprint, reviewing design specifications for BMP materials, that's prior to a construction inspection, and then also reviewing plant specifications, identifying the O&M requirements and triggers prior to an O&M inspection, and reviewing previous inspection documentation. Use of the inspection protocol for three types of inspections. So basically, you're using the same protocol with different elements in each protocol during the actual inspection. So during the inspection, you are verifying BMP existence, location, footprint, and type of configuration. You're identifying the conveyance to the BMP and BMP inlets and outlets. You're confirming the BMP drainage area, identifying if the BMP needs maintenance and what type during your O&M inspection. You're taking photographs, and you should be using an inspection form or a mobile program such as the SMC Clean BMP tracking tool. So for LID and GSI construction inspections, inspections during the construction of LID and GSI projects are critical to ensure that the LID and GSI measures are constructed per the approved design with acceptable materials and that proper construction procedures are implemented. BMP inspections are recommended at each stage of construction. At least one inspection should take place, but several inspections are optimal to observe the various stages of construction of an LID GSI measure. And as an example, for a bioretention system, inspection should be completed at completion of initial excavation, placement of the aggregate layer, placement of the bioretention soil media, and placement of the bioretention plants. LID and GSI project construction inspections should include verification of the presence, location, footprint, type, and configuration of each LID GSI measure, evaluate if the LID GSI measure is built per the approved design plans, and that's based on the stage of construction completion, verify that the LID GSI measure inlets, outlets, and invert are at the design plan elevations, evaluate if the correct BMP materials are used and installed correctly, and identify if machinery performing excavation is adjacent to and not inside the BMP footprint, because that can cause compaction. Evaluate if the LID and GSI BMP is being protected from construction traffic and debris. This prevents compaction, sedimentation, and construction pollutants. Additionally, the LID GSI project construction inspection should confirm the drainage area contributing runoff to the LID GSI measure, evaluate the condition of the drainage area, including land use and intensity, status of the surrounding construction, and surface cover condition to identify the potential sources of pollutants getting into the GSI system. Should also evaluate the placement of the bioretention soil media, planting of bioretention plants, and evaluate if proper construction sequencing is being implemented. The LID GSI BMP measure is one of the last items that should be constructed on site. Excavation for the LID and GSI BMP is completed only after construction is complete of the adjacent area. Taking photographs of the LID GS measure is also what should be done during construction inspections. The next inspection is the LID GSI commissioning inspection. A commissioning inspection is performed as a final check to ensure that measures were built per design plans. Similar to other commissioning of other infrastructure or buildings. This can occur concurrently with updates to reports and recording of maintenance agreements depending upon jurisdiction. If any modifications to design are made, changes should be documented in the as-built for that particular system. Documentation of the inspection is needed for verification. Additionally, commissioning inspection should verify the existence, location, footprint, type, and configuration of your LID and GSI measure. Evaluate if the LID and GSI measure is built in size per the approved design plans. Identify the conveyance to the LID and GSI measure, and verify that the measure inlets, outlets, invert are all at the design plan elevations. Confirm that the drainage area contributing to the runoff to the LID and GSI measure, and evaluate the condition of the drainage area, including the land use and intensity, the status of surrounding construction, and surface condition. We want to make sure that the drainage area is fully stabilized. Identify if the overflow structure is at the proper elevation, and of course take photographs of the LID and GSI measure areas. LID and GSI projects commissioning inspection also includes evaluating vegetation. Many of the LID and GSI systems integrate vegetation as part of their components, and so evaluating vegetation is critical. If vegetation is planted per the specifications or identified plant list is a critical component to proper functioning of the system. So you're evaluating that. You're also evaluating if the vegetation percent coverage, placement, and spacing is consistent with the planting plan. You also want to look to make sure that the proper mulch has been used. We don't want to use wood mulch because that will float. You're going to evaluate also if the BMP is offline until you have adequate vegetation establishment, or you'll see erosion from stormwater entering the system. And then finally, you're going to evaluate if the irrigation system is installed per the irrigation plan and is functioning properly. For LID and GSI operation and maintenance inspections, these are usually performed on an annual basis to ensure that the LID and GSI measures are adequately maintained and functioning. These are also called conditional assessments. Some LID and GSI BMPs are required to be inspected after significant storm events in some jurisdictions. LID and GSI structural measures are subject to sediment, trash, and other debris, which can build up and impede infiltration or biofiltration. Excess vegetation can also reduce infiltration or biofiltration. LID and GSI measures lacking proper vegetation density however, can cause erosion of sediment to occur. Maintenance requirements should be included in the LID and GSI O&M plan, and that should be reviewed prior to going on to inspection. Additionally, O&M inspection should verify the LID and GSI measure existence, location, footprint, and type of configuration, evaluate if the GSI measure is built in size per the approved design plans, and identify the conveyance to the LID GSI measures, verifying that the measure inlets, outlets, invert are at the design plan elevations. Should also confirm the drainage area contributing to runoff to the LID and GSI measure, and evaluate the condition of the drainage area, including land use and intensity, status of surrounding construction, and surface cover condition. Again, we want to make sure that the drainage area is stabilized. We want to identify if the overflow structure and outlet is at the proper elevation, and if any short circuiting is occurring within the system. Additionally, O&M inspection should identify if maintenance is needed per the maintenance triggers in the O&M plan, including visible erosion, which may require energy dissipation or an addition of vegetation. You're evaluating the vegetation specifically if you observe plants installed per the specifications in the identified plant list, if the vegetation percent coverage and placement and spacing is consistent with the planning plan, and if proper mulch has been used and whether it needs replacement. Additionally, if vegetation removal is required, such as invasive woody or dead vegetation. Sediment accumulation in inlets and for the LID and GSI measure should also be evaluated. You're also looking for the presence of trash and debris, and whether the capacity of the LID GSI measure is reduced by sediment and vegetation. Additionally, you want to check infiltration rates with simple infiltration tests. And finally, you do want to take photographs of the LID and GSI measures. The inspection checklists that are included here provide examples of paper checklists, although I highly recommend using an electronic form. These are checklists for construction and commissioning. And what you have here is a post-construction BMP verification form that identifies the inspection type, either during construction or commissioning inspection. You're looking at identifying the facility name and address, owner information, the type of system, what's the land uses in the drainage area, and then you're answering all of those questions as far as, is the BMP present? What type of BMP is it? Essentially, the location and footprint of the BMP, does it match what's in the BMP plans? And you're answering that for each BMP on site. Then, at the end of the inspection, you should be following up with either the site owner or the site manager to go through any deficiencies that you've identified, and specifically the contractor during construction. Similarly, for inspection checklists for O&M, you're identifying all the different information specific on the condition of the BMP, the type of BMP, location, and all the relevant information that we've just gone through. Again, you're reviewing the inspection at conclusion of the inspection with the site owner or manager to identify any BMP deficiencies that have happened. With that, this concludes Module 3.3, and I've